What is the percentage of sulfur in sulfur 4 oxide? The options are given below. In this question, the first thing we have to determine is to write the correct chemical formula. So the correct chemical formula for sulfur 4 oxide is SO2, where the atomic mass of sulfur is equal to 32.0. Percentage by mass of sulfur in SO2 is given as percentage by mass of sulfur in SO2 is given as the molar mass of sulfur from the compound divided by the molar mass of SO2 times 100. This is the formula that is going to be used to determine the percentage of sulfur in SO2. Now, the molar mass of sulfur is equal to 32.0, and the molar mass of the compound SO2 is equal to, we have SO2, so which is S plus O2. S plus O2. So we are going to substitute the respective masses into this, which is equal to S is given as 32 plus O is given as 16. So that would be 16 times 2. 16 times 2. The molar mass of sulfur is given as 32 plus 16 times 2 is 32, 64 gram per mole. At this point, we are going to substitute this into this formula. Percentage by mass of sulfur in this compound is given as equal to, mass of sulfur is given as 32 divided by molar mass of SO2 is given as 64 times 100. So at this point, we are having 32 times 100 all divided by 64. 50%. Let us examine the options. The correct option is option D, 50%. A gas X diffuses twice as fast as Y. If the relative molar mass of X is 32, calculate the relative molecular mass of Y. This question on the board could only be solved in accordance to Graham's law of diffusion. Now, before jumping into a calculation, let us state the law. Graham's law of diffusion states that at a constant temperature and pressure, the rate of a diffusion of a gas is inversely proportional to the square root of its density, or we can say that to the square root of its molar mass. Now, according to the relationship, we establish this formula that the rate R is inversely proportional to 1 over the square root of the molar mass. Now, from the question, a gas X diffuses twice as fast as the gas Y. That is to say, the rate of the gas X over the rate of the gas Y is equal to square root of, since the law states that the rate of a diffusion of gas is inversely proportional, that is to say, it will become the mass of the molar mass of Y divided by the molar mass of X. Inversely proportional. The molar mass of Y divided by the molar mass of X. Now from the parameters Rx and Ry, they are called the rate of diffusion, whereas Mx and Ny, they are the molar mass. From the question, gas X diffuses twice as fast as gas Y. That is to say, gas X, Rx, is 2 times Ry. If you divide both sides by Ry, so we can obtain this equation. Ry cancels Ry, we are left that Rx over Ry is equal to 2. Rx over Ry is equal to 2. From the question, the mass of X is 32. Mass of X is 32. The molar mass of X, that is Mx is equal to 32. At this point, this parameter is given as 2, which is this. And again, Mx is given, Mx is known, so we are going to determine My on the board. The formula is Rx over Ry is equal to square root of My over Mx. Okay, let's substitute this into the equation. Rx over Ry is equal to 2. So that becomes 2 is equal to square root of My over Mx. We are required to determine the value of My. My over Mx is given as 32. 2 is equal to square root of My over 32. We are going to take the square root of both sides. Taking the square root of both sides, we have 2 squared and this raised to the power of 2. So these two cancel the square root. 2 raised to the power of 2 is 4, and 4 is equal to My over 32. Making My the subject, My is equal to 32 times 4. That becomes 128. So the correct answer is 128, and the right option on the board is option A. 128. 200 cm3 of a gas at 25 degrees Celsius exerts a pressure of 700 mm Hg. Calculate its pressure if its volume increases 350 cm3 at 750 degrees Celsius. The options are given below. We are going to apply the general gas law, that is the combination of Boyle's law and Charles law. But before then, let us write the general parameters given on the board. We have 200 cm3, which is V1. The initial volume is given as 200 cm3 of a gas at 25 degrees Celsius. T1 initial temperature is equal to 25 degrees Celsius. We can't use the 25 degrees Celsius, we have to convert this to Kelvin. To do that, it becomes plus 273, and this will give 298 Kelvin. Exert the pressure of 700 millimeter mercury. So the pressure P1 is equal to 700 millimeter mercury. Calculate its pressure. P2 is unknown. Calculate its pressure if its volume increases 350 cm3. V2, the final volume is given as 350 centimeters cube at 75 degrees Celsius. So the final temperature T2 is equal to 75 degrees Celsius. You also have to convert the temperature from degrees Celsius to Kelvin by adding plus 273. So this will yield 348 Kelvin. Next thing is to write the general gas law formula. General gas law formula is P1 V1 all over T1 is equal to P2 V2 all over T2, where P1, V1 and T1 are the initial condition, whereas P2, V2 and T2 are the final conditions. We are required to make P2 the subject of the formula. From this equation, making P2 the subject of the formula, P2 is equal to, if you cross and multiply, we have P1 V1 times T2 all divided by V2 T1. So we have P1 V1 T1 T2 rather P1 V1 and T2 all divided by V2 times T1 V2 times T1. So we are going to make use of this equation to determine the value of P2, which is the final pressure given. I have to bring the equation over to the right hand side so we can solve over here. So this is equal to, by substitution, P1 on the board is given as 700 times V1 is 200 times T2 is 348 Kelvin, all divided by V2 on the board is given as 350 times, and T1 is given as 298 Kelvin. 463 67.11 millimeter mercury. So P2 is equal to 467.11 millimeter mercury, which is the final pressure required. And the correct option on the board is option C, 467.11 millimeter mercury. Beryllium and aluminium have similar properties because they're dashed. So the options are given below. The two elements on the board are beryllium and aluminium. Beryllium, Be, has an atomic number of 4. That is to say, the electronic configuration of beryllium is 2, 2. Beryllium belongs to group 2, period 2. So it belongs to group 2 and period 2. Let us examine the next element, which is aluminium. Aluminium, its symbol is Al, and it has an atomic number of 13. Electronic configuration of aluminium is 2, 8, and 3. So aluminium belongs to group 3, period 3. Group 3 and period 1, 2, 3. Beryllium belongs to group 2. The atom share is 2, which states the group, and the number of period is 2, number of cycles or number of shares. Aluminium belongs to group 3 because the atom share electron is 3, which states its group, and period 3, number of cycles or number of shares is 3, 1, 2, 3. So aluminium belongs to group 3 and period 3. They are not in the same group, neither are they in the same period. Yet they show similar chemical properties. Now these chemical properties is what we call diagonal relationship. Certain elements in the periodic table that are placed diagonal to each other exhibit similar properties. So the correct option on the board is option D. They are positioned diagonally to each other. Option D. Which of the following is correct about the element? The options are given below. The first thing we have to determine is to note the total number of electrons in this element. So we have 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. And 12 plus 5 is 17. So we have the total number of 17 electrons. There are 17 in number. So let us determine the group and the behavior of this element. To determine the group, we draw the electronic configuration 2, 8, and 7, that is 17. Or we can draw the electronic shell. The first shell, which is the K shell, has the maximum number of 2 electrons. Then the next shell has 8, can hold the maximum of 8 electrons. So we have 10, remainder 7. 1, 2, 3, 4, 5, 6, and 7. That is the total of 17 electrons. This element belongs to group 7 in the periodic table because it has 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. It belongs to group 7. They are very reactive during chemical reaction. They tend to accept 1 electrons during chemical reaction to become a univalent anion. Because this element belongs to group 7, we can say that they are halogens. They are called halogens because of their salt formation or their salt formats. So the correct option on the board is option D. It is a halogen because of their salt formats.